this tomorrow. There are a couple of these problems on there. Couple meaning, well, really a couple too. And like I said, it's really you have to do elimination more than once. We'll get into how many times when we start. Okay, so note packets out, calculators out, because we do have some word problems, obviously some bigger numbers. Now, you are going to have systems now that have 3 equations most of the time. There is one unique case we're going to see today. 3 equations with 3 variables in them. So you're going to have x, y, and z. Now this first one, this is probably the favorite of all of them, is what we call in triangular form, and that makes triangle. You've got one of the answers. So of course if you know z is 3, we can just back substitute our way through it. So if I was going to do this one, I'm going to put 3 in this one for z. So 2 times 3 is 6. And easy enough, you can figure out y. And then I would take those and plug them in the first equation and get x, which we're going to do all the way through here in example 1. So sometimes, not very often, you get lucky and you get this triangular system where they give you one of the answers. So let's, of course, throw the 2 in here. 3 times 2. So we can do that in our heads. So we have z, we have y. Obviously, I need x. So I'm just going to write it down here so I have a little bit of room. So I'm going to replace the y with -1. So I'm just doing a little mental math here. -2, -1, +2. Put a 2 in for z, 3 times 2. And you probably can mental math that even. X is going to be what? 1. Yeah.
1.
Now, as always, I don't care if you leave your answers circled like that. You can always write them ordered pair style. Now, when you have more than one variable, the ordered pair, or in this case, ordered triple, always alphabetical. You're going to do x, y, which I said y, I just didn't write y, and then we're going to do, of course, z, which they gave you. If you want to write it ordered triple style, you do not have to. Sometimes I like to be fancy and do that. So even if, I just last hour, the trig class had a quiz. Gosh, I'm so mean to them. I gave them 4 equations, 4 variables. So they had to solve for x, y, z, and w. So, So W would be at the back. You would just always go alphabetical. The looks on your faces is really priceless right now. Okay, I like it. I like it a lot. All right, let's get into it. Now, not so lucky. Here we go, people. We have limited time today. Keep it together. Now, not so lucky on this one, of course, because we don't have that triangular system of equations. So, we're going to use elimination. Can you use substitution? Yes, but they don't really like substitution. Everybody rather use elimination. So, first thing I'm going to do, just to keep my work organized, you don't have to. I like to always number my equations so you know what I'm working on. Basically, unless we have some sort of unique case, like maybe a no solution or something you could spot a little earlier, you generally end up doing elimination 3 times. That's why I gave you so much space. So just be conscientious of that. First mission, I'm going to scan through the letters, X's, Y's, Z's. I'm going to try to make a good choice. What do you think looks like the easiest variable to eliminate? X. The X's look pretty easy. And I'm definitely going to do X. Everybody's gut instinct is X. Honestly though, I would probably do Z if I was doing it. Why do I say that?
You can times it by 0.
It's only in 2 of the equations.
It's only in 2 of the equations. I could save myself some work if I did that, but I'd have bigger numbers. So gut instinct, X. Let's take X out of the first 2 equations. So I'm going to stack the first 2 together. I'm going to write them nice and pretty. We're not going to have any sign errors. Keyword there, right? And we're going to add these together. Of course, the x's cancel. I have 1y. Don't forget your 3z. 9 minus 4, 5. Easy enough. Now, we have not worked with the third equation. My second round of elimination. I got to work with the other equation I have not. Since you took x out of this, I want to take x out of the third one. Let me get the third one written up here. Now, we took x out of the first round of elimination. I want to take the same variable out of this round. Now, it does not matter if you pair up 1 or 2 with it, but clearly we're going to have to do a little multiplying to get x to cancel. I would probably do the second equation, and I'm just going to times it by a 2, so that way I have a negative 2 there. So I'm going to put 2 times in front of it, so you know I'm multiplying it by 2. So 6y and negative 4. So add them up. X's are gone. 1y, 5z, 11.
It's negative.
Did I miss add?
You times it by 2.
Yes, that's what you're supposed to do.
Yeah, but the negative.
Oh, I forgot the 4. I forgot the 4. I see what you're saying. 12, right? No, good catch, good catch. I'm telling you, it's what happened in the bathroom.
Well, it's 2.
Let me pause the video. Very sheltered. Okay. All right, so this is going to be 9. Riley, how's it looking? 9? Okay. I'm traumatized by that. Okay. All right, so your goal is, now your 2 answers have 2 equations, 2 variables. So now it's like yesterday. I can stack these together. You could use substitution if you wanted, but everybody, loves elimination more, so that's what I'm going to do. Let's make it easy. I could get the y's out of these pretty easily if one had a negative on them. So I'm just going to pick one. I'm going to run a negative through this, and I'm just going to stack it underneath. And hopefully I don't make any sign errors. No promises. So my y's are gone, negative 2z. And we get a nice pretty answer for z. Okay, now,
Oh, I thought you were.
just like all the other systems, you kind of work your way back to the top. You quote unquote, of course, back substitute. So I'm going to go to either this red answer, actually probably the green one because I have room to write under it, and I'm going to replace the z with a 2 and figure out what y is. So if we put a 2 in here, 5 times 2, 10. Subtract 10 off, negative 1. So of course we need x. So now we have to go back to one of the original equations to figure out x. Doesn't matter which one, I just pick what looks easiest. Honestly, I'd probably do the second one because you're missing a term, a little less work for you. So I'm going to do that guy. 3 times y, so 3 times negative 1. I'm going to add 3 over, and of course x is 1. So still, I think overall kind of simple, but it's time consuming. It's super time consuming because you have to basically do elimination 3 times. Now, I could have saved you one of the rounds of elimination because we talked about this earlier. If you decided to take z's out, you could have then stacked that answer with the second one and skipped one of the rounds of elimination. But you're going to have to make those 15 z's, have a little bigger numbers, so it depends if you want to handle that or not. Choices, my friends. Not a lot of choices here. We have all the variables and all the equations. So scan through. What looks easiest, do you think, to get rid of? X, Y's, or Z's? I don't care. Sounds like Y. Okay. So obviously the easiest ones to get Y out of would be the top and bottom equation, so I'm going to start with those. All right, so x, 3x, 4x, 3z minus 5z, negative 2z, and then 4. So whichever equation you haven't worked with, that one's in play now, so the second one. So I'm going to jot him down. And okay, this sounds very like common sense, I know. Make sure you don't write your z's that look like a 2. I always have some poor kid that their z looks like a 2 and it throws everything off. Details in the writing. Okay, so we took y out of this. We're going to take y out of this guy. So you pair it up. Do you want to use which equation with it? Make a good choice. I would do which one? I like it. All right, add them up. 2x. Negative 1z, 3z, 2z. So you should be down to, of course, 2 equations, 2 variables. My first gut instinct was like, oh, I'm going to divide or reduce all these by 2. I don't know if I'm really going to do it. Because aren't your z's set up to eliminate? Yeah. If they weren't, I would reduce it and then work on it. I'm just gonna stack this guy under here. So we're gonna have 6x and 18 comes out nice, 3. And now, of course, we just back substitute our way through the system. So I'm going to use this green equation just for the mirror's sake. I have room to write under it. I'm going to put a 3 in here for x, so 2 times 3, 6. So subtract 6 off, 14 minus 6, 8. Z is 4. And to one of the top equations, last letter we have to figure out, of course, times z, 3 times 4, 12, equals 1. All right, you solve it. What do you got for y? I already have it. Y equals, you just waiting for somebody to do it, Owen?
I did it.
So, you should, yeah. And again, you're welcome to leave the answers like that or go order triple style X, Y, Z. Doesn't matter to me. So again, time consuming. Name of the game.
What is this?
Okay, let's get into some fun stuff now.
Where's the
Now, when you are in 3 variables, x, y, and z, of course we're in 3-dimensional space. We've seen that. So we're not having lines that intersect, we're having planes. So we have seen this. Infinitely many solutions. You know, I like to write it IMS. We've seen where they do not intersect. No solution. And then, of course, we've already seen a couple cases where they intersect and are 1 point are ordered triple. So let's look at some unique cases, shall we? All right, call it. Do you want to get rid of x, y, or z? Doesn't matter. I don't, yeah, x probably, they're the smallest numbers. I'd probably do x also. Let's number them here quick. So I'm going to do, let's do the top and bottom, but I'm going to run a negative through the third equation. So I'm going to leave the top one alone. And I'm going to take the third one, and I'm just going to put a little negative out there. I'm just going to run a negative through it. So gone are the x's, negative 5y, 4z, and 2. So process is the same here. Okay, we haven't worked with the second equation, so that's my next thing I'm going to jot down. You pick, do you want to put 1 or 3 with it? You got a preference? Yeah. Let's just do 1. And I'm going to run a negative 2 through that guy. All right, let's total this up. 5y minus 4z equals 0. Now, some of you right now, and I already hear us mumbling answers, hopefully can look at it and get the final answer. Guesses? No solution. Because if I stack these together, of course, the entire left side cancels. We're going to have 0 equals 2, which we know is a big fat lie. No solution. So you can obviously have those kind of unique case answers today, too. Let's see what you think this one's going to be. I feel like I'm getting predictable in my old age. Maybe, maybe not. We'll see. We'll see.
Yes.
We'll see. We'll see. Maybe it's not. You don't know
It
yet.
definitely is.
All right. What are you eliminating?
The first and the last of X.
So you're doing 1 and 3 and getting X out. Yeah, I like it. I'd probably do that too.
And then Y minus 0.
All right. X's are gone. 3y. Don't forget your minus 3z. And don't forget your 0. Now, here's the nice thing about this one. We haven't worked with 2. I'm going to jot it down. Now, this is kind of like that first problem we did where I said if we made those z's the 15s and got rid of it, it would have saved me a round of elimination. That's this here. Because your second equation already has the x out, so you can just stack it with, you can just go ahead and stack it, and you've got your two equations, two variables. Or you look at these equations and realize they're really what? The same. Because if I divide the red by 3, isn't it the green?
Yeah.
2 4s, 3 6, 4 8's, all the same thing, right? Answer. Infinitely many solutions when it's the same equation. They really enter it. Now I've got something fun for you. Hold on to your hats, kid. Don't start the next one. Now, get ready for this. This is going to be fun. You're really going to like it. So one of the things we want to do, we want to kick it up a notch, obviously. When you have infinitely many solutions, we're big kids. We're not just going to leave it IMS anymore, okay?
Write it out.
Funny, Avery. We want to come up with a pattern or the formulas that generate all the possible answers to this. So, get ready for it. I'm going to write my little order triple. So, as always, remember you back substitute. So I'm starting at the back or I'm starting at Z. So the first thing we're going to do is instead of using Z, we're just going to switch the variable so we're all on the same wavelength. So first thing you're going to do is replace Z with A. I forgot to replace. I'm running out of room here. Replace. I need to write smaller. Z with A. Now, why A? I have no actually magical answer for you for that. That's just a systematic process, so we're all using the same variable. Now, no different if this was a 7. You would plug in 7 for Z and you would figure out what Y is. So I'm just going to go back to this one. This is nice and easy. So if I put an A in here and I solve for it, I get the same thing, which you're like, why are we doing this? Wait for it, wait for it, wait for it. Now, let's go back to an equation that has X. I'm going to do the third one. So Y, we're using A. And I'm going to solve for X. So I'm going to subtract the 2A over. And then, of course, I would have to switch the signs. So I'm going to go ahead and put it in my order triple as 2A minus 1. Now, you don't have to write this, just look at this. But this gives you the formula, so to speak, to generate all the answers. If I pick a number for A, I'm going to pick something small so I can mental math it. Let's pick 2. This would be 2. 2 times 2, 4 minus 1, 3. If you plug those 3 numbers in all 3 equations, they'll work. Pick another small number. 7. 7. 2 times 7, 14 minus 1, 13. If you put in 13, 7, 7, it will work in all the equations. So you're coming up with the formulas that would give you all the infinitely many solutions. So that is the new exciting part to IMS today. Elliot.
So it's like you find an ordered pair, choose a variable, and then find all of the coordinates in terms of that variable?
Yes, everything you said is correct. All right, ready for the next unique case of the day?
No.
Okay, very enthusiastic.
You have one solution.
Now, first off, it's not a typo. We really should have how many equations? 3. However many variables you have is how many equations you need to get a distinct answer. So if you have 4 variables, you need 4 equations if you're going to get an answer. Lord help us all. So we right away have fewer equations than variables. That automatically puts it to IMS.
What the heck?
They would intersect everywhere. Fewer equations than variable.
Why exactly?
Because they'll intersect everywhere. Because you don't have that third equation, so they'll meet up at every point. Now, here's the bad part. We have to do the Z as A shenanigans.
Why?
Oh, I do not like those shenanigans.
Okay? Now, we haven't done anything to the systems as far as elimination or done anything with that, okay? So we do need to simplify those 2 equations down. There are too many variables in it. Gut instinct, everybody who just wants to add them and get rid of Z. But we're using Z to define our answers. Never get rid of Z. So, I'm going to do X. So I'm going to run a -2 through this guy. Okay, now add them up. And let's work smarter, not harder. I'm going to reduce that all by 3 while I'm here. Now, I want to get my expression for y. So, I'm going to rewrite this. Think of that as an a instead of a z. And I would add a over. Now we have to go back and figure out what x is, of course. I'm going to use that very top equation. X minus 2 times y. Y I've got a minus 1 though. Z I've got a. And now I'm just going to distribute, yada yada, solve for x. So let's combine our a's. The 2's are going to cancel, which is fine. So I'm going to have x minus a equals 0. Got it. So that will give you the pattern for all the infinitely many solutions. So my pro tip of the day, this is why I specifically made this system, everybody wants to get rid of the z's because it's easiest. I understand that. Never get rid of the z. Even when I'm back on some of these earlier problems, okay? My gut instinct might be to get rid of z, but if it goes to IMS, you need z to define the other variables. So I never get rid of, even if it's the easiest, I never get rid of z first. I always do x or y, so I don't end up having to do extra work at the end if it's an IMS. That is my pro tip of the day. Are you ready for some word problems? Okay. Love the enthusiasm. How about this? I feel like once you get the equations set up, you can solve them. So let's just focus on getting the equations set up because I want to return some homework to you before your quiz tomorrow. All right, now, 3 equations, 3 variables. Let's just number away here. So, small corporation borrowed $775,000 to expand its software line. Some of the money, bless you. Some of the money is borrowed at 8%, 9%. We've seen 2%. We've seen 2. We're adding in the third now, 10%. How much is borrowed at each rate? Interest. Interest always goes with percentages with $67,000. And we'll deal with that last sentence in a minute. So you have 3 different funds, of course, X, Y, and Z. So the total amount of money borrowed should total up to the $775,000. My next equation, the percents always go with the interest. So I'm kind of just adjusting this red equation. I'm going to put the percents on. So 0.08x, 0.09y. I'm going decimal because I don't have percent key of a graphing calculator. And of course, our interest, $67,000. Man, I'd like to make that an interest. Okay, final equation. Think about this. The amount borrowed at 8% was 4 times the amount at 10%. Okay, so read it close. First off, which variable is the 8% variable? X. Was is the past form of is. What does is mean in math? 4 times. I don't know if we really need the dot, but there it is. Okay, the amount borrowed at 10%. Look close. What's your amount at 10%? What letter? Z. So the amount borrowed at 8% is 4 times 10%. So if you borrow $3,000 for Z, you get $12,000 for X. 4 times the amount. Now, it looks, you're like, oh man, now we got to do like substitute or elimination 3 times. This is going to be awful. Actually, it wouldn't be. Work smart, not hard. Okay. X is 4Z. I would replace both of these with a 4Z, or X, sorry, X with 4Z. I'm telling you, I'm never going to the restroom before this class again because I'm too scared. Just for the record. Okay, 4Z. And you'll get it down to 2 equations, 2 variables. So I'm going to rewrite this top one. I'm going to write it in red, keep it in red to match. But if that's 4Z, 1Z, I'm going to total those to 5Z. less than a 0. There we go. And then let's do this green one. You might need your calculator for this. What's 0.08 times 4? 0.32 plus 0.10. So I'm going to rewrite that one 0.09y plus 0.42z. So now you have your two equations. You could honestly, I don't know if I do elimination on this one because of the decimals. This might be a good substitution. Maybe solve the top for y and plug it into the bottom. For the sake of time though, because I want to make sure we get the next set of equations, I'm just going to give you the answers. And I don't know why I made these numbers so awful. They're bad. I'm like, I don't know why I made this problem so bad. I regret it, like I said. I know. I regret the crazy numbers. I should have, yeah. Just for the record. Now, remember, there will be word problems on your quiz tomorrow, but for this section, I just gave you a couple, 3 equations, 3 variables. The word problems are not from this section. Previous. Okay, let's just, for the sake of time, because like I said, I want to give you your homework back, get some equations set up for this guy. Nicole started a new diet, of course she did, that requires each meal to have 460 calories, 6 grams of fiber, and 11 grams of fat. So clearly you can see we're writing equations for fiber, fat, and calories, what we got going here. Table shows for each serving, for the breakfast, whatever, nobody cares. How many servings of each food should Nicole eat to follow her diet? Okay, so we're gonna write one equation for the fiber, one for the fat, one for the calories. Let's start with the fiber. I'm gonna do this one in green. Okay, so for the toast, I'm assuming you were using X, Y, and Z, right? So 2 grams for toast. I'm not putting 0y for the cottage cheese since she didn't eat any. Let's just put 2z for the fruit. Now, how many total grams of fiber is she aiming for? 6. And let's be real, I would probably, before I start solving, I'd probably divide that all by 2. Which, in a minute. Let's do an equation for the fat. We do that one in red. So 1 gram on that one. I'm not writing 1, I'm just putting X. 5 for the Y for the cottage cheese. Let's not put 0. Seems obnoxious. How many total grams of fat is she trying to eat? 11. And then we're going to do 1 for the calories. I'm going to do that one in blue. And this is a 2. So 100X, 120Y, 60 on the Z. And how many total calories is she trying to eat? 460. Now, is there any real shortcuts to solving this system? Not really. I mean, maybe take like y out of these two and you could stack it with this one that's missing a y. So you could maybe save yourself a little bit of work on the elimination. But like I said, for the sake of time, I'm just going to give you the answers because I want to be able to give you back some homework here before we go. Okay, x you end up with 1, y is 2, z is 2. And I should probably label these. How many servings of each food should she eat? So that's our 1 for, of course, our fiber, for our toast. Let's just cottage cheese, whatever. And then let's do fruit. I'm not going to get too crazed on the label. Okay, so like I said, on your quiz tomorrow, there are a couple problems from this section, but they're more like the beginning. The 3 equations with the 3 variables. I didn't pick word problems from this section. There are word problems on it from the previous sections, and I make sure I know that, like headwind, tailwind, airplane one we did. There's my other pro tip of the day. Okay, all right, so let me grab your homework like I said.